Hey everybody, welcome back. Now that we have begun the topic of cloud computing, we are going to go through some of the basics in this lesson, the other one, the one after that, so you can feel confident about really understanding what cloud computing is about. Um, at this point, it would be pretty hard not to um, have stumbled upon cloud computing in one way or another because it's already pretty much everywhere for quite some time. Um, but of course, in case you had any gaps or just wasn't sure about anything regarding cloud computing, um, I hope that we'll be able to to basically fill those gaps during the next several lessons. Okay, so first we're going to talk about some of the key characteristics of cloud computing. And this is important because this is going to be on the exam, of course, and you need to make sure you understand each one of these um, and to be able to explain them, of course. So let's go with the first one. So first you have on-demand self-service. Now, what does this mean in relation to cloud computing? Well, all of you who have ever logged into, let's say, AWS or Azure or GCP and so on and so forth, um, you know what the experience is on the inside, to put it this way. So on-demand self-service means that um, when you decide that you want to begin using cloud computing, you're pretty much um, deciding to use a toolbox, right? So you don't have the solutions readily available, even though you do have them ready to an extent, depending on the type of um, cloud computing that you're using. And we're going to talk about this down the road. But for now, let's just say that you are just paying for the tools, right? But you decide what to do with these tools. So if you want to stand up your own application, that's fine. And put it in the cloud, that's fine. You would get all the tools you need in order to do that, but they're not going to build the application for you, right? You still need to do it yourself. So this is why it's on-demand self-service model, because once you log into AWS, for example, you have the ability to use all the services that they provide, and to make whatever you want with them, right? It's sky's the limit pretty much. Um, so this, all these characteristics that we're talking about right now, when you're thinking about them, also think about them, you know, it's a comparison to what it looks like when you have, all of this on-prem, right? Compare this, compare these characteristics to the characteristics of the on-premises infrastructure, and you easily see what why these are not only characteristics but also benefits of the cloud computing um, model. So this is the first one, right? Next, you have broad network access. Um, Obviously, when we're talking about cloud, we're talking about something that's um, entirely beyond your company's network, right? So with broad network access, what we mean is that you could pretty much access your cloud resources in whatever way you want, through whatever form factor you want. Um, you could lock it down and only access it by VPN. You could, make some of the resources freely available openly available for accessing from everywhere around the world. You could make them public resources. Um, you could pretty much do whatever you want network-wise. So broad network access in that regard means that um, let's say if you want to let's say you're creating an S3 bucket, for example, right? You decide how that bucket could be accessed, and you're also responsible for making sure that you configure the network, for example, for the for all the virtual servers that you'll be using in the cloud, right? So all of this broad network access that you have in place is among the cloud computing characteristics. Next, you have rapid elasticity and scalability. Now, these are a bit confusing, and it's kind of normal if you mix them up initially, or if you confuse one for the other. But they're different, right? They're not the same thing, even though um, every now and then you might see or hear somebody wrongfully using them synonymously, but they're not the same thing. So elasticity basically refers to the dynamic allocation of resources, um, short-term allocation of resources right on the spot, right? This is basically how the cloud is working to begin with. So let's say you need more CPU, more memory at a certain point that could be provided to you dynamically, and then next thing you know, you don't need these resources anymore. You need to go back to where you were before that. That's fine. Those, these could be taken away from you, and they won't be allocated to you anymore because you don't need them anymore, right? So think of elasticity as the dynamic allocation of resources for the short term, right? And this is important because um, it can be long term if it's dynamic, right? It's short term because it's dynamic, because it's trying to be adaptive, it's trying to adapt to whatever needs you have at a certain point in time. On the other hand, scalability it has two parts, right? The first part is scaling up. The second one is scaling out. Think of scaling up as um, the allocation of um, think of it as, let's say you have a server which you're using for something, right? So if you want to scale up, if at a certain point the demand towards this server becomes greater, then you could just add more horsepower to the server, right? You could just make the server bulkier in terms of resources, and then you're going to basically scale up in order to meet your needs. While scaling out would be, um, instead of adding more to that particular server, you could just add a second and a third one and basically scale out. But this is more static than elasticity, right? Because elasticity is adapting to your needs, while scalability is trying to meet your needs um, at their highest point, to put it this way, right? Either scaling up or scaling out. So let's say that you're now a 500 employee strong company, but the next thing you know, you become a 1,500 employee strong company, and um, your demands and requirements triple, right? So the cloud is able to address that by either having more horsepower being put into a single server and scaling it up, or by scaling out and adding more servers in order for you to meet your needs, right? Resource pooling is an important one. So think of it as so what is the cloud in essence, right? It's basically someone else's resources which they're providing to you, but they're not only providing them to you, right? They're also providing them to um, a gigantic list of customers which are using these resources. So resource pooling in that regard would be, the fact that the cloud provider is um, delivering the resources in a way that it meets the needs of all of its customers. So let's say that, just for the sake of making up an example, let's say that a cloud customer has, a cloud provider has 1,000 customers. Then if they have 100,000 servers, which they're operating with, they're going to, for example, on server one, you're going to have customer one, customer two, and customer three, and they wouldn't know about each other, but they would actually be sharing the same resources on the same server. Now, on server two, you're going to have customer one again, but then also customer 14 and customer 16. And in the same manner, the public cloud provider is going to do this resource pooling in order for all of the customers to be able to share resources and to meet whatever needs they have. Okay. Next, you have measured service. This is one of the greatest benefits of cloud computing, because you're only paying for what you have used, and unlike on-premises infrastructure where you need to have enough resources to meet your needs and a little bit on top of that so that you're not on the edge all the time. With cloud computing, it's you're being billed only for what you have used based on the pricing that you have initially agreed on. So it's a measured service. It's it's not like you're just saying, okay, hey, cloud provider, here's $10,000 a month, and I'm gonna do whatever I want, within this amount. It's more like you're being billed only for what you have used, and again, that depends on the particular service, but it's a measured service, and this is why it's so efficient in terms of it's more, I think the proper term is probably cost effective, right? It's cost effective because of the fact that you don't have to waste money on resources that you're not going to use. You could literally build your cloud environment in a way that you really minimize the amount of excessive spend that you have per month or per year, for that matter, right? And then you have multi-tenancy. Now, multi-tenancy is a term that's very close to the resource pooling that we've already talked about. In order for you to have resource pooling to begin with, you need to have multiple tenants, using your cloud infrastructure. Otherwise, it's not gonna work, right? And at the same time, in order, if you have multiple tenants, then you need to be doing resource pooling, because otherwise, it's not gonna work again. But when we're talking about multi-tenancy, you need to be thinking about some other things as well. Like, for example, also think about the fact that all of these customers, not only do they have to share the resources, not only do they have to make use of this resource pooling, but they also have to have enough segregation and segmentation between them, so that nobody is able to, for example, snatch someone else's resources, or attack someone else that they're sharing a common infrastructure with, and so on and so forth. So multi-tenancy is also about making sure that all of these customers are working, within their own silos, so that when customer one is using resources on server A, they don't know that other customers are using resources on that same server as well, right? And they don't know that these other customers exist. They don't know who they are. They cannot access their infrastructure, the infrastructure that they're using, and so on and so forth. So make sure to keep that in mind as well when talking about multi-tenancy. Okay, thank you, and I'll see you in the next one.